Here we have 5 equal masses, capital M. They are equally spaced on the arc of the semicircle of the radius 2 meters. A mass of small m is placed at the center of the curvature of the arc. What is the magnitude of the force on mass m due to the other 5 masses? Okay, now to make it more clear, I just labeled them M1, capital M2, and so on. Okay, let's first consider then the force between M and the capital M1. Okay, so say this one is F1, okay, and the force between M5 and M1, let's make it F5, okay. Now, since they're equally spaced and the masses of M1 and M5 are the same, so these forces will cancel each other, okay? So there's net force becomes a 0. Now, let's look at the force between M1 and M2. Okay, since they are directed at a certain angle, and we know that angle this one is 45 degrees, this force can be resolved into two components. So one component will be basically, I call this one F2x component, then this one will be F2 y component, okay. Then let's look at the force between M4 and M. Again, it's 45 degrees, so therefore F4 will be F4 will have two components, F4y component and then F4x component, right? So again, as you can see here, all the x components will cancel each other. Why? Because they're same mass and same radius. So we can conclude that we will consider only the y component of the forces, okay? So therefore we can say that F net is equal, so all directed at the same direction, then we can say that F4y plus F2y plus F3. F3 is the force between M3 and M, okay? Now, so here let's continue, so bottom side, F net, F4y is equal to what? It's equal to the G M4, sorry, capital M and M4 divided by the radius squared, and since we're taking only the y component, so this is a 45 degree, then this will be cosine 45 degrees, okay, plus G M M2 divided by the r squared, and since we're taking the y component, then it becomes cosine 45 degrees, and then plus F3 is just G M3 M divided by the radius squared. So that's it.